Hi, it's Dan again with D&D Thorough Home Inspections, and in today's video, it's kind of going to serve as part 2 to last week's video. We're going to talk about some of the electrical hazards associated with outlets. We're going to talk about open grounds, false grounds, and also reverse polarity. So whenever we go to test outlets, we use this little outlet tester right here. You simply just plug it into an outlet, and a combination of these 3 lights will light up, letting us know what type of defect is associated with that outlet. Now, ever since 1962, the NEC has stated that every outlet needs to be grounded. So the first thing we're going to talk about is open grounds. Got a little mock draft here. As you can see, you may already know or have learned from the previous video that the long slot is going to be your neutral and the short slot is going to be your hot. So as you can see on the back here, we got the neutral being the white wire to the longer slot, and then the black wire being your hot to the shorter one. But this ground here is not connected. That should be connected to this green ground screw. So if this was actually live and we plugged this in, that middle light would light up, showing us that it is an open ground. The next thing I want to talk about is your false grounds or bootleg grounds. And that's when somebody takes a jumper from your neutral port down to your ground. As you can see here, they've got a jumper from the neutral going to the ground. And the reason that's an issue is because when your current goes out on the hot wire, the black wire there, and tries to complete the circuit on this neutral wire, well, now you've got a jumper going down to the ground, making it live. And the second part to that is there's no ground hooked up. So if something were to happen, say a wire gets severed or cut, there's no alternate path for that current to complete the circuit, potentially creating a shock hazard. And just a little fun fact, most of your surge protectors will not work without a ground. Now, the last thing I want to talk about is reverse polarity. And that's when you've got your 2 wires reversed. So as you can see, here's the short outlet, which should be your hot, but we've got the neutral connected to it. Then your hot is connected to the longer outlet, which should be your neutral. Other than that, this looks like it's wired up right. You got your ground in there and both your hot and neutrals connected. Now, the reason reverse polarity is a shock hazard is because let's say we've got a toaster plugged in here. That toaster is potentially live even though that lever on the toaster is not pushed down, because most of the time your switches are connected on the hot line. So if somebody were to stick a knife in here, let's say, that current is potentially live in there and could present a shock hazard. So that's pretty much going to do it for this video. I hope you guys learned something from it, or at least enjoyed it. But please remember to like, share, subscribe, and stay tuned. Thanks, and have a great day.